skipping section 4 of chapter 4, which would have been systems of linear equations with 3 variables, x, y, and z. Now, a similar method is used to solve them. Usually it's elimination. And then you eliminate one, and then you eliminate another, and then you solve for that variable, and then go through the system. But generally speaking, the problems take a long time to solve, and they're just lots of steps. So we skip that in our Math 1103 course. So we're going on now to section 5, which would be where we're going to use systems of linear equations and solve word problems. Okay, so that's basically what we're doing. So in example 1, they're talking about predicting equal consumption of red meat and poultry. And you can read through this, but basically they have 2 equations, this one and this one. Now notice this one has positive slope, this one has negative slope. Well, the one for negative slope is for red meat, and the one for positive slope is poultry. And what are they saying? Well, they're saying that at sometimes in the future, there's going to be a time where if we made sort of a line here going through these points and making a line going through these points here, can you see what's going to happen sometime in the future? That these lines are going to intersect. And they're going to intersect some point in time. This is 2011 down here. So 2025 maybe out there, that these will intersect. At that time, the amount of red meat sold and the amount of poultry sold will be the same. And that's what they're showing us here as background. But how can we solve this? Well, let's go on a little bit here, because this is a word problem. They're giving you all of the steps. In this case, here are our 2 equations. And what technique could you use? Well, the technique you could use here would be, notice that y equals this, y equals that. We could say that y equals y. So we're going to set it up that this section of the equation equals this section of the equation, and that's what they do right there. So let's bring it up. And when they solve for x, they get x is this. Now, what did we say x was? Well, this is time. So we started in the year 2000, if you can go back and look at that graph. So what will be 2000 added to this? Well, it would be 2034. So sometimes within that year, we can predict that the consumption of red meat will be the same as the consumption of poultry. And this has to do with health. Most people seem to think poultry is a healthier food than red meat. But we'll let you discuss that in health class. Okay, let's go on to the next one here. So once again, they are reviewing the steps of problem solving that we first looked at in Chapter 2. All right, example 2, finding unknown numbers. Now we did some like this in Chapter 2, but let's see what we have here. Find two numbers whose sum is 37. Well, since we're allowed to use two variables, we're going to say the first number, x, plus the second number, y, equals 37. Then, and these two numbers have a difference of 21. So we can do that. X minus y equals 21. So we've set up two linear equations in two variables. And you might say, well, what technique can I use to solve it here? Well, it's quite obvious. You're going to make a line, and then you're just going to add these up. This is going to be 2x. Here, these cancel out, and I get 58. Now I divide both sides by 2, and I get x equals 29. Well, if x is 29, what will y be? Well, you just put it up here. 29 plus y equals 37. So 37 minus 29, this is going to be a 8. So we can also check it now. If this is 29, 29 minus 8, is that 21? Yes. So our ordered pair, or our two numbers, are 29 and 8. Again, they're starting us off with a rather easy one, but showing you the technique and using the skill of problem solving again. So there's our 29, and there's our 8. Okay, example 3. And at least the sentences are short here. So we'll read that over. A first number is 4 less than a second number. Well, we're going to call our first number x and our second number y. So our first equation will be x is 4 less than y. Four times the first number, which we're saying is x. So 4x is an equal sign, 6 more than twice the second. Well, this is the second, so it's twice the second plus 6. So the first number is 4 less than the second number. Okay, that one checks out. 4 times the first number, 4 times the first number is 6 more than twice the second. So what do we do now? Well, we know that x is this, and what would work very well is we're going to use substitution. So we're going to go 4 times what x is, which is y minus 4, equals 2y plus 6. So this is going to be 4y minus 16 equals 2y plus 6. Transpose, I get 2y. Transpose, I get a positive 22. Divide both sides by 2, I get y equals 11. So I go up to our first equation there, where I can substitute an 11. 11 minus 4x will equal 7. 7, 11. Oh, that's nice. And we can check it, and I believe that works. Now again, the steps of solving an equation: understanding it, translating it into an equation, the second part into a second equation, and then using substitution, we get our first value. Then we get our second value. Okay. Solving a problem about prices. Now, as we look at that, we see the Circuit du Soleil, a little kind of a French word here, is performing locally. Matinee admission for adults and 2 children are this, while admission for 2 adults and 3 children are this. Well, that one's sort of easy. Let's see. Remember when we said we can use like A for adults and C for children to help us identify? This is the case. So let's do the first one. So for A, for adult tickets, again, this is the number of adults. Well, I'm sorry, this is the price of the adult tickets. 4 times that price plus 2 times the price of children's tickets would be $374. For adult, again, we don't know how much the adult tickets cost. That's why we're calling that price A, the adult price. We have 4 times that price is going to give us a sum of money. 2 times the children's price will give us a sum of money, and that sum of money is this. Now, when we go 2 adults plus 3 children, and the same idea works, this price is now $285. So you might say, well, how do we solve it? Well, substitution wouldn't be good particularly, although you could. If you divided everything here by 2, you'd get a single C here. And then, but I think the way to do this one would be elimination. So let's use a little strategy on this. We want to modify both of these equations so that something will cancel out. Now, if we want our A's to cancel out, well, we only have to modify this equation, actually. So we're going to modify this, and we don't have to modify that. If we're going to do the C's, we'd have to multiply both of them. But here we can just modify this. So, no change here. In a sense, multiply by 1. No change. Here we're going to multiply this by a negative 2. So my first equation up here stays the same. 4a plus 2c equals 374. Now this is going to become a negative 4a because we are eliminating this. This becomes a negative 6c, and this now becomes a negative 570. So these cancel out nicely. Here I'm left with a negative 4c, and then I just have to subtract that. Get my nice trusty calculator out, and that becomes a negative 196. Now I'm going to divide, and this is important. It's a negative 4 on this side. So whatever you do to that side, negative 4, we get C equals 49. So we now have the price of the child's ticket, 49. We put there 98 here. 2 times C would be 98. We're going to subtract 98 from both sides and then divide by 4. Okay, well, I'm pretty sure you can do the math, and they have it all laid out here as well. So also they're using A for adults and C for students. Let's see what they use to solve it. So they got the child's ticket was 49. They replaced the 49 in the first equation like we did. Got a 98. They're subtracting 98 from both sides. They're dividing both sides now by 4. And you get A equals 69. Now notice you're asked, what are the prices of the tickets? So be sure to say that the adult is 69 and the child's price is 49. And of course these are in dollars. And if you were to check it, everything would match. Okay? Now did we forget something here? I don't think so. Let's go back and look. Yes, there was letter C. We identified the adult ticket, the child's ticket, but then suppose that a special rate of $1,000 is offered for a group of 20 persons. Should a group of 4 adults and 16 children use this group rate? Why or why not? Now, if they did it regularly, that would be 4 adults at 69, 16 children at 49. That would be $160. I'm sorry, $1,060. So, by using the special group rate of 1,000, they would save $60. So, it would be a good idea to use the group rate. Okay, and you might say, well, how come I didn't know that? Well, I don't know if you've noticed, but I don't read the textbook ahead. I try to do it as if I were a student, scanning the text, looking at the text, and then giving my 2 cents. Okay, as I will do here as well. 2 cars leave Indianapolis, one traveling east, I like that, and one west. After 3 hours, they are this many miles apart. If one car is traveling at 5 miles per hour faster than the other, what is the speed of each? Well, as you read this, you're going to find that you're using this formula, distance equals rate times time. So let's follow it here. So the speed of one car we're going to call x. The speed of the other car we're going to call y. So we know the distance is rate times time. So one car's distance is this. The other car's distance is that. So there's our first equation in a sense, because this car's distance plus this car's distance is going to be that. So 3x plus 3y, in fact, let's just move it up here. In this case is going to be 297. And we know that one car is speed is x and the other one is y plus 5. So there are our two equations. Now, the key is, what technique do you use to solve this? Think about it for a moment. If you said substitution, you are correct. So we're going to take the x value, which is y plus 5, put it into the equation, and solve it, and we get y is 47. So if y is 47, what is x? Well, 47 plus 5. That would be 52. So the ordered pair is this, but the interpretation is that one car travels at 52 miles per hour and the other at 47. So this is what you're going to have to put into MATLAB. And often in this section there's a number of sub-questions, and each one takes a while to read it, put it into a system of equations. Now, interestingly, this one can be solved with just one variable, but here we're practicing working on two. Now, we did some like this in Chapter 2, mixing solutions, but again, that we can use two variables makes it actually a little bit easier. So let's read this over. We have a pharmacist, 70 liters of 50% alcohol. Well, one solution is going to be X. The other solution will be Y, the concentrations, or the amount of them. And all together, we're going to make 70 liters. So when you get a problem like this is what you can sort of pick out. Any kind of mixing. How much do you need altogether? 70. So part of it will be the X and part of it will be the Y. We don't know what the distribution is. We do that on the next one. What kind of alcohol do we have? Well, we have 30%. Well, we're going to call that the X amount. This is 30% here. And this is 80% will be the Y. And we're going to get a 50% solution of this. So 30% of X plus 80% of y equals 50% of our total amount, which is 70. Now, just as a little review, how did we do that before? Well, we said we have a container that stood for 70, and a portion of that was x, and the other portion was x minus, let's say 70 minus x. I was saying it right, I was writing it wrong. But now we can say our two solutions, this one's x, we're going to call this y. And you'll see something that happens too. So this is our two equations now. How would you solve it? Well, I want to get rid of decimals. And I can multiply everything by 2 to follow through. And this now becomes 30x plus 80y equals, now 5 times 7 is 35, and I have 2 zeros. So there's my new second equation. And what is my first equation going to be? Well, what is x? X, or what is y, I should say? Y is going to be 70 minus x. And you might say, oh, look over there. Yes, when we were doing it with one variable, that's how we got our second term. And in a sense, this is how it ties in. So what do we do here? Well, where we have our y, we're going to put this in. So it'll be 30x plus 80 times 70 minus x equals 3,500. Now I could continue solving that, but let's look at what they're giving us here as well. So there's our number of liters of the first solution, of the second solution. Here's its strength. So this is the amount of alcohol, and we want to have 70 liters at a 50% strength, and then that is our equation. X plus y equals 70. 30% of x, 80% of y equals 50% of 70. And notice they didn't use substitution. Okay. Could you do it by elimination? Yes. And they're not getting rid of the decimals either, so it just goes to show you. But you get the same answer either way. I should have worked on that other one to show you it would work, but it does. So y is 70. Well, what is y? Y was the 80% solution. So we have to subtract 28 from 70 to get 42. So your answer interpretation or answer statement is that we will need 42 liters of 30%, 28 liters of 80% to end up with a 70 liter solution of 50%. And we did that by using systems of equations, putting our data in, and using a kind of chart. I didn't use one this time, but you can use it if you like. And again, having this in your notes and then practicing it is your model to how to do other equations that are similar to this. Again, you could have done it with one variable, but here they're featuring two. Okay, let's go on. Now, here's another kind of problem that they're featuring, and it's a very useful one. And often they do this in function notation, that the cost of making a product is the startup fees for capital investment plus the cost of making each item. Now, when you sell something, you get revenue. And revenue would be the price you are going to sell that product for, and then the number of items that you produce. So this X and this X, in a sense, are the same, but what differs is this. So here they're saying a company recently purchased $3,000 of new equipment that we're going to put here to produce stationery. The cost of producing a package of personal stationery is $3. So that's the cost of producing each package of stationery. But this is your startup cost. Now, they have decided that they're going to sell this for $5.50. Now, I could put the extra zero there, but I'll leave it off. That's $5.50 for every item they sell. Now, if you were to make a graph of this, this one starts at 3,000 here, and it goes up by 3. So you're going to have a line that looks like so. Okay? Now, when you start to sell things, you start here at 0. You didn't sell any. But since this is only increasing by 3, that's the slope in a sense. This is 5.5. There's going to be a point up here where the revenue exceeds the cost. And at this point, we call that point the break-even point. So this is a little bit of economics. So how do you find out what that break-even point is? Well, remember we said we could substitute function notation with a y, and this function notation with a y. So we have y equals this, and y equals that. Just like we had for the red meat and poultry at the beginning. So we're going to have 5.5x equals 3x plus 3,000. We're going to subtract 3x from both sides. We get 2.5x equals 3,000. We're going to divide both sides by 2.5. And we're going to get x equals, and I'm going to get my little calculator out here. And x equals 1,200. Now, what is the significance of that 1,200? Well, when you sell 1,200 units down here, you have met your break-even point. So by selling 1,201, you now have made some profit. Okay. And hopefully going to sell, 2,000 or 3,000 of them. Then, you can make a profit. But keep in mind that this assumes that that's the cost of labor, electricity, and all the other things involved in the production of that. This was your capital investment. I don't know if any of you worked in, when you were in high school, you did junior achievement. I did. And I was the president, actually, of my company. Okay. So, we did things like this. What would be our capital investment? We sold stock and all that stuff. We won't go into it right now. Okay. Now, in this case, this is finding measurements of an angle, and this involves an X, Y, Z that we're not going to do. So I'm going to skip this. This one is in your book. You won't be getting 3 variables to do. And this completes it just at 36 minutes.